Let's continue our conference and let's start next session. And am I right? You are the first speaker, yeah?
Yes.
Okay. The title of the contribution is "What software architecture styles are popular?" Please welcome.
Okay, thank you. Can you confirm that you can hear me and you can see my presentation?
Yeah, everything is okay. You may continue.
Okay, thank you very much. So, hi to everyone. My name is Mgaran Nikolai, and today I would like to give you insights into which architecture styles are popular in modern development. This research was developed by our team, by my mentor, Mitsuk Alexey, from the Laboratory of Process-Aware Information Systems, and by me. So, when we were starting the research, we found out that there is a lot of literature in software engineering on code smells identification, on architecture smells identification. And there are a lot of listings and description or abstract descriptions of software architecture styles. And still there weren't a clue on how to identify the usage in real code and with what frameworks or with what to begin when you want to apply a certain architecture styles. So I and my mentor decided to get deep into this topic. First of all, we have to estimate the value of the topic to the community of developers, practitioners, developers. The next thing, we have to develop a set of empirical features by using which we can identify the usage of software architecture styles. The third step will be to process some open source code to get some statistics on which styles are used. And the fourth step will be to validate the features. To the first step, we held a survey among the developers, practitioners, developers. We asked them questions about their experience, about their job area, about programming languages, and the most important questions were about their attitudes toward architecture styles. 111 developers took part in our survey. From the graph, you can see that their experience distributed normally. It means that there is not so much developers with extreme value of experience, like less than a year or more than 20 years. And there are a lot of developers with the middle age experience from 2 years to 19, 20 years. The next question was about job area. Here you can see that our developers participated in the most popular area nowadays, with the most of them participating in front-end development and back-end development. On the questions about technologies and programming languages, our developers answered in this manner. We can see that such languages as C#, C++, Python, Java, SQL, they are usually appears in the top 10 languages of the TOB language, of the TOB index. So on this step, we can conclude that the sample of our developers was representative and we can rely on its answers. First answer dedicated to software architecture styles was whether our developers explicitly apply the concept of styles when they design their applications. Here we can see that only a quarter of them do not apply the concept explicitly. This is still a lot. But the next question was about to find out, do they really value this concept? We asked the developers whether their colleagues apply these concepts. And here we can see that only 15% think that the concept of architecture styles is not applied in their whole sphere. Then we choose 11 certain styles and asked developers whether they think it's possible to identify the usage of styles manually or automatically. And the results were astonishing. So here you can see that most of our developers apply these styles in their practice. However, a prevalent amount of them think that styles cannot be identified automatically, and only like third think that they can't even identify styles manually. So what we can conclude for now? We can conclude that developers apply and value the concepts of architecture styles, but they are not so sure about the identification of these styles. So on the next step, we have to scope our research and to choose styles for which we will process the open source code. Here you can see 11 chosen styles. This list includes such orthodox style as model view controller and event-driven software, and such non-orthodox styles like machine learning-based and cloud service-based. This precise list was created in order to cover all the modern insights and tendencies in the modern software. And now I would like to present you the features, the empirical features, which were used to identify these styles. So for 9 out of 11 styles, we created framework-based features. It means that for every style, we outlined a set of frameworks by using which we can identify the usage of the certain style. Here you can see an example for model view controller with language Python and framework Django. And for the last two software styles, main subprograms and reflection using software, we created a language-based features. That means that as features, we created some language constructions. Here you can see an example of reflection using software with Python language. And now, how are we processing the open source code? As a source of open source code, we choose GitHub. We developed Python crawlers, which were using PyGitHub library. All the data was stored at Google Drive. We have to limit the amount of repositories on GitHub, and we choose 10 technological giant companies and communities. You can see them here. Moreover, we have to choose languages in which the repositories have to be developed, and we choose Python and Java as these languages because they were the most popular languages in our survey and in the TIOB index. And now I would like to present you the results of our mining. From the graph, you can see that the most frequent users of MVC in Java repositories are Microsoft, IBM, and Apache. They apply MVC style in almost 20% of their repositories. On the other hand, you can see that other companies apply MVC not so much. Here we can see a more smoother application of MVC from 5% to 10% of almost all companies consist this style. Moreover, you can see that on the previous slide, Spring was the most frequent framework by which the usage of MVC was identified. And here you can see that the prevalent framework is Django. Now I would like to present you the results of main and subprograms. Here we merged all the repositories from all the companies without partitioning, and we searched whether the main function were used and whether the constructors were not applied. Here you can see that almost none of the repositories apply main and subprograms style, and we could expect it from the Java for knowing him as the class-based language. A little bit another picture can be observed in the Python repositories. Here, about 4% of the repositories apply the main and subprogram style. So we could also expect this from the Python language, as it's famous for being used in experiments. Here you can see the results of the event-driven style in Java repositories. We identified the usage of this style by applying 7 frameworks. You can see that mostly event-driven is applied by Apache, and the most frequent frameworks being used with this style are Kafka and Amazon ActiveMQ. In Python repositories, we can see almost the same picture. Event-driven is still applied by AWS and Apache, and the most prevalent frameworks are ActiveMQ and Kafka, as in the previous language. With reflection, we have applied the same method as with main and subprograms. We created 17 features for Java repositories, and from the picture, we can see that only 351 repositories out of almost 1,500 do not consist any reflection features, and the most amount, about 2/3, 66%, consist from 1 to 8 features. The same picture we can see with Python repositories. There are more repositories with 0 features, but there is a lot of repositories with 1 to 7 reflection features. Here I would like to show the results for other styles without going deep into framework side. So here we can see that data-centric style is the outlier style because it's applied almost everywhere, with Microsoft, IBM, Google, and Apache being the most frequent users. We can also see that other styles weren't applied in any repositories of other companies, with such exceptions as cloud-based and AWS company. We can observe 25 repositories there, and with expert systems and Apache. But these cases can be thought of like outliers because Apache has a special framework, Apache Gen, and AWS has a special framework for cloud services. So it doesn't apply to all the other companies. Almost the same picture we can observe in Python repositories, with one exception. Here, one of the most popular styles is ML-based style. It's being used almost everywhere in almost half repositories of every company. The next step in our research was the validation of the created set of features. To do this, we created a survey among GitHub developers. We used the Python mailing code snippets and Google tables to process the results. At the end, we have counted the precision, recall, and F1 score to validate the results. So what can be seen from this picture? First of all, we get the answers from the developers for 78 repositories. However, we did not manage to get any positive results for main and subprograms, expert systems, and container styles, which means that we have not validated the results of our research for these styles, and that more sophisticated methods have to be used. The next thing we can say is that for some styles, as reflection and for reflection and data-centric and MVC, precision and recall were almost the same. So we can conclude that this set of features is a good starting point for future features create. The next thing that we can say is that recall seemed to be very low for such styles as cloud-based, aspect-oriented, and reactive-based, and precision tends to be overall normal. So we can conclude that for some of these styles, a more accurate set of features have to be created in order to cover most of the cases. So in conclusion, I would like to repeat points made in this presentation. So first of all, developers community applies the concept and it values the concept of styles, of architecture styles. However, the community underestimates the ability to identify usage of styles. And the next thing is that a simple set of features can be created, being framework-based or language-based features, in order to get insights into what software architecture styles are popular today, even though they are used heterogeneously from company to company. So thank you for listening to me, and I would gladly answer your questions.
Okay, thank you very much. Any questions? Okay, I have a question. Could you show a slide with the list of architecture styles you selected for research?
Yes.
Oh, okay, thank you. My question is concerning methodology of your research. I didn't see the strict definition of architecture style. From my point of view, it's very important because in your list, very different things are presented. For example, model view controller looks like template. Yeah, from one side. From another side, data-centric software or event-driven software. Two last so-called architecture styles look like properties of problem domain than style that can be used during development of these applications.
So
that's only two cases, and I could give you some another examples. And as I understand, you absolutely need a good definition of architecture style. Maybe you can give it right now.
yes, we agree. I agree with you, and we applied such a definition that software architecture style is any constraint that can be applied to the architecture of the software. And I agree that this list may be a little bit heterogeneous, and it was created in order to cover the modern tendencies. And the description of the styles, a short description, can be found in the article of every style. Yeah.
Okay, thank you. Any other questions? Okay, thank you very much for your presentation.
Thank you.
Okay, next speaker. Next speaker. Who is the next speaker?
Yeah, it is me.
Okay. Am I right? The title of the contribution is Integration of Microservice as Component in Model Environments for Low-Code Development. Yeah?
Yes, right.
Okay. You're welcome.
Thank you very much. Let me share my screen. Can you please confirm if you can see my screen and hear me?
Yeah, yeah.
Okay, right.
Okay.
Thank you. Hello, everyone. My name is Ahmed Chaudhary, and I'm a researcher in Confirmed Smart Manufacturing Research Center, University of Limerick. And in collaboration with Professor Dr. Tiziana Margarilla, today we are presenting our joint work, that is integration of microservices as components in modeling environment for low-code development. The agenda of the presentation is following. So, the low-code development environments are gaining attention as a potential development paradigm in the future IT. My pointer is visible. Okay, right. These platforms enable their users to design and develop applications with minimal coding knowledge. For example, with the support of drag and drop components, drag and drop visual interfaces that acts as encapsulated code wrappers. The aim of these platforms is to produce flexible, cost-effective, and rapid applications in model-driven way. The main challenges associated with traditional development approaches are the complexity in the development at large scale, the maintenance over time, the adoption to the dynamic requirements and upgrades. It also systematically excludes the application domain experts from the process. At the same time, the cost of quality documentation and training of new human resource are the other concerns for the organizations. So according to Gartner, the low-code development environment market will be increased by nearly 30% from year 2020 to 2021 and reaching a value of $5.8 billion in value. Generally, the software systems are not isolated in nature, especially web applications in internet-centered ecosystems and digital threads in Industry 4.0 context. They demand interaction with various external services, libraries, and systems. And these frequent needs could be to acquire data from external systems, feed data to external dashboards for analytics and publishing, utilize the compute power of cloud systems, and reuse the sophisticated enterprise cloud services. Domain-specific languages encapsulates most complexities of the underlying domain application. These encapsulation of code and abstraction in models empower domain experts to take advantage of these platforms without having a deep expertise in software development. Most domain-specific languages today are at coding level, but not leverages at model-driven development at platform level. So in this context, microservices also plays an important role to design software services as a suite of independently deployable components with the purpose of modularity, reusability, and autonomy. Different versions of these services may coexist in a system as a set of loosely coupled collaborative components and must be independently replaceable without impacting the operation of heterogeneous systems. So model-driven development tends to promote domain experts to a code developer role. Low-code programming, both at API and platform level, is considered to be a game changer. This paper proposes the integration of microservices as components, as draggable components into graphical modeling development environments based on formal methods that are DIME and Pyro. These domain-specific languages virtualizes the technological aspects of the services and delivering a simple, coherent, and efficient extensions to both of these platforms. We extended DIME, that is an offline Eclipse-based general-purpose modeling environment to develop web applications, and we integrated general REST services as a component over here. The second integration is on Pyrus, that is a collaborative web-based special-purpose model-driven environment for data analytics, and we integrated Amazon Web Services over here. And this extension and integration with external systems through service components extend the capabilities of these platforms to meet the wider needs of communication and also take advantage of existing sophisticated enterprise cloud services. So a brief overview of these integrated modeling environments. The aim of domain-specific languages is to minimize the knowledge gap between domain experts and software developers. But the efforts to develop these tools from scratch is enormous because of the sheer cost and complexities of them managing their code, its quality, and its support. So Synco plays a role over here. This is a meta-level platform that wipes out these challenges by providing the required domain-specific graphic modeling and code generation capabilities. Synco products are, one can easily define the properties and extend the functionalities of Synco and develop their own products. So here we will consider two Synco products that are Dime and Pyro. Dime is a J2EE Eclipse-based Synco product for the designing of web applications on basis of graphical drag and drop DSLs. One can easily model and develop general aspect of ordinary web applications. That could be data model, GUI model, businesses, and roles and security. Dime supports both control flow and data flow, and it automatically provides the facility of consistency checks to avoid any sort of interconnectivity errors. In contrast to Dime, Pyro is a web-based Synco product that runs on a browser, and it turns a browser into a collaborative domain-specific graphic modeling environment for data flow applications. Right now, Pyro only supports data flow, but not the control flow. And the data exchange is happened in a REST-based asynchronous communication, and the platform must be deployed on local or remote server and should be accessible via browser. We will now see that how we extended the Dime and Pyrus with the RESTful and cloud AWS services respectively. So the first integration is RESTful extension of Dime. To develop a generic service-independent block SIB in Dime that communicates with the REST services, we will extend the Dime functionality using the support of native library that it provides. In Dime multi-model type architecture, the business process model is where the new SIB will be utilized. So existing architecture is extended with the addition of native library as a new block. This new native block will be merged to the model during the automated code generation step, and the extended functionality will be integrated as a Java code with the remaining application during compile time. So in this way, it will not add any additional performance penalties. To interact with proposed SIB, we developed a REST service that is implemented in ordinary PHP and deployed that on an external server. This ordinary REST service basically handles the request by this client SIB, and this basically provides the list of country names on the basis of country code. For example, it will return United Kingdom in case of UK country code. So now to create a client SIB that interacts with these REST services, there are two steps that are required. The first one is SIB declaration, and the second one is SIB implementation. As in figure 2, we can see that this is a signature of SIB declaration that started with the SIB keyword, followed by the SIB name, whatever it is, followed by colon, and the attached Java code that should be invoked whenever this SIB would be used in Canvas. So the following next lines carries the list of inputs and their data types. And finally, the different outputs and the control flow branches are defined that are called on basis of the required input. Once these signatures and the attached Java code are validated by the underlying platform, this SIB would be visible as a drag and drop component in this SIB Explorer section, and this would be ready to use as a draggable component. So here in figure shows the visual representation of the newly developed SIB. The required inputs can be fed as a either data flow or as a static value. And after that, the result will be passed to the next successive SIB, whatever it is. After the insertion and data connectivity of SIB, DIME automatically validates for semantic and syntactic errors at the project level and model level, ensuring the correctness of the intended behavior that can be seen here in figure 5. And this is the overall pipeline and interface of the DIME. This is the project explorer section. This is the project validation section, both at project level and model level. This is the canvas and the general pipeline, and this is the SIB Explorer section. So the next extension is in the other platform, that is Pyrus. Pyrus is an online data analytics platform built using Pyro. Pyrus communicates asynchronously with Jupyter Hub at the backend, and RESTful protocol is used to read and execute the function signatures and the attached Python code respectively. We have integrated few of Amazon Web Services, and here as a case study, we will only discuss Amazon Translate service. So the mechanism for the new block declaration and implementation is similar to the DIME SIB. As Pyrus only supports data flow, so it only contains the signatures. As in figure 8, the signature declaration starts with the hash keyword, followed by the metadata, and finally the implementation of the Python code that must be located in attached Jupyter space. Pyrus automatically reads the signature and show them as a draggable component that can be dragged in the canvas, which can be seen over here. And right now, all these are automatically validated and highlighted as red because the data flow is not connected yet. So this is the overall pipeline of AWS Translate. Logically, we can divide this workflow into two phases: initialization phase and implementation phase. For the initialization block, it basically meets the precondition of the external server in order to use its services. And here for a valid session, we must provide a server region name, access key, and secret key. And after the validation from the attached AWS server, it will provide us a session key that will be passed as an input to the next block, alongside with other required inputs. For example, the sample string to be translated and to and from code of the languages. And after this translation, finally the translated string is passed to the next block for the printing on screen. And these pipelines are automatically validated by the underlying modeling platform for connectivity errors of these blocks. The tools and technologies used for these implementations and extensions are DIME, Java, Eclipse, JSON library, PHP, Pyrus, Python, Jupyter Hub, AWS. And to summarize, we presented a generic extension mechanism that follows a microservice philosophy to two low-code development environments. As the methodology is simple and generic, so it can be followed like a blueprint for the integration of large variety of external services and platforms to enrich these DSLs. We integrated pre-existing RESTful services in DIME and cloud-based enterprise services as a draggable components here in Pyrus. Regarding future work, the next application domains will be data visualization layer and streaming platform layer. Our colleague Rifreshia Khan is already working on integration of visualization layer. Also, the development of cross-platform integrations like particularly R language and support of machine learning and analytics functionality, both in DIME and Pyrus, is also in progress. These are the related references. And lastly, I would like to mention that this work was supported by the Science Foundation Ireland grants for two of its research centers that are Lero and Confirm. Thank you. If you have any questions, feel free to ask.
Thank you. Dear colleagues, any questions, please? Yeah.
Hello, thank you for your talk. My name is Anton. I have the following question. So, sorry. Yes. So, the first is like preliminary question. Did I understand right that your work makes some analog of orchestrators for microservices?
Sorry, I didn't understand your question.
Excuse me, what?
Can you please repeat your question?
Sorry. Yeah. Did I understand right that your work creates some analog of orchestration systems for microservices?
Yeah, basically, we followed the philosophy of microservices. That is basically modularity, reusability, and autonomy. And we followed the same philosophy and doing integrations of these different platforms as a independent components, as a draggable components, basically.
Okay, thank you. And the second question, then, if if comparing to maybe some popular microservices orchestrators, yes, like Conductor and others, and maybe some other orchestrator, for example, we even can use Kubernetes for microservices orchestration. So what advantages of your work comparing to some popular, some existing orchestrator systems?
Yeah, basically, we are developing and extending our platform level model driven development system. And basically, the difference between simple microservices and this integration is that we can extend the functionalities of these systems to integrate different microservices as draggable components. That's basically the difference. And these can be extended, for example, following the analogy of microservices. For example, if a new upgrade or version of library is there, we simply need to replace this component without affecting the any implementation of the application.
Okay, thank you.
Okay. Any more questions, dear colleagues? No questions. Thank you. Thank you very much. And let's go further. Next speaker.
Thank you.
The title of the next presentation is Historical Civil Registration Record Translation Using an Extreme Model-Driven Approach.
Hello.
Hello. Yeah, welcome.
You can see my screen, right?
Yeah, right.
Okay. Hello. I would like to thank Spring Summer Young Researchers Colloquium of Software Engineering for giving me this opportunity to present our paper, which is entitled as Historical Civil Registration Record Transcription Using Extreme Model-Driven Development. The authors are me, Rafleisha Khan, Alexander Sivek, Chiara Bonac, and Tatiana Margaria. In this presentation, I'm going to discuss about our project DBD-IRL, Ireland 1864 to 1922. It's a data-driven public history research project in digital humanities that uses historical death registration data to build a big data interoperability framework largely based on knowledge discovery process. These are the objectives I'm going to discuss today. In the digital humanities, the digital twin concept upholds a massive potential to transform the landscape of how digital humanity methods can assist in the representation, analysis, and understanding of past, which in turn can provide useful learning for the present and future. Developing a mirror of a traditional digital humanities record system through digital twins is time-consuming, complicated, and requires deep interdisciplinary knowledge in the humanities domain and software development. To reduce the discipline-specific knowledge...
Excuse me, so to interrupt you, but...
DBD-IRL adopts
excuse me.
kind of model-driven...
Sorry? very, very fast. I cannot follow you. Could you don't speak so fast, please?
Okay. Sorry. Am I still sharing?
We cannot see your shared screen. Cannot see right now.
Sorry about that.
Designed.
Sorry. Let me share again.
Some problems with Zoom on your computer.
Yeah, sorry, I'll try sharing again. Now I'm sharing?
Okay, yeah, now it's okay. Yeah, yeah.
So, to start?
Yeah, yeah, okay, yeah.
Sorry about that. In the digital humanities, the digital twin concept uphold a massive potential to transform the landscape of how digital humanity methods can assist in representation, analysis, and understanding of our past, which in turn can provide useful learning for the present and future. Developing a mirror of traditional digital humanity record system through the digital lens, it's time-consuming, complicated, and requires deep interdisciplinary knowledge in the humanities and software development. To reduce the domain-specific knowledge gap between humanities and technology, our project DBD-IRL adopts a specific kind of model-driven design called XMDD, which combines historians' understanding of big data with complex computer scientist tools and methodologies. In the main contribution of this paper, I would like to enlist that developing a model-driven web application, which I'm going to refer as Historian app for storing Irish civil registration data, specifically death registration data from 1864 to 1922, introducing a database of subsequent digital data analysis by producing a semantic and clean data source for the death records, illustrating the impact of MDD approach on non-programmers on the adaptation and evolution of Historian app from its first version to the current one. And finally, showcasing the use of DIME, a specific low-code application design framework where stakeholders can develop their specific application without any coding knowledge. The General Register Office has given us a data dump of death registration record from 1864 to 1922. So we received TIFF files, which are high-resolution images of actual register and the corresponding Excel sheet for the data entry. Every single TIFF file enlists 1 to 10 individual death record with 11 properties each. Well, these data is currently available at irishgenealogy.ie as TIFF files, which are not really suitable for any kind of analysis operation. So we wanted to transcribe these data and prepare them for research purpose. Now I would like to explain why we are not using natural language processing tool. So if we concentrate on the data sample or TIFF file, we can say that these data are handwritten text, not typed ones. They are written by different registers and superintendents, which make them high number of variety with writing patterns. So for handling the data variety, any text processing tool would need a large corpus with all these different patterns as training set. Also, very few existing tools extract text as different properties. Apart from that, accurate text extraction need a well-trained model with huge and precisely labeled data, which is not really available right now. Also, there exists a scalability issue when uploading millions of records into a server. So all these lead us to the development of an web application for the DBD-IRS data entry that helps the user to insert the death records correctly and form a digital database. But DBD-IRL is just not about developing an application and handing over to the stakeholder, which in our case is historians. And that's why we're adopting a programming-less low-code approach based on integrated modeling environment so that the historians can prepare and participate in the building of their own application, and in future they can maintain the application on their own. Since the emergence of UML and its predecessor, several MDD approaches have been proposed in the literature to address the generation of code from model representing various aspects of a system, including telecommunication, web client application, automatic extraction, robotic, smartphone, etc. Extreme model-driven development approach is a low-code approach that combines several software engineering and programming paradigms such as agility, model-driven development, service-oriented development, formal method, extreme programming, and full code generation, etc. The agile model-based approach helps repeat feedback and co-design cycles with the historian in a continuous refinement project. In addition, using model helps the developers team in reflecting, presenting, and explaining their work in progress to the historians and the historian in understanding and monitoring the development. Now I'm presenting the collaborative development of the DBT-IRL's application in an integrated modeling environment. Sorry. The project lifecycle started by collecting and analyzing historians' requirement, and at this phase, the historians used their expert knowledge about handling historical data and correctness of the record. And the computer scientists started designing the data models, including entities, attributes, and relationships. Then the historian specified how they want the data to be stored and explained that what is already there and what is needed. Also, then the CS team designed the corresponding data flow models expressing high-level application logic and elementary operations. The second phase includes all the XMDD model refinement, followed by DSL extension and implementation of the new functionalities. Here, the historians participated as stakeholders for detailed question and the CS team as fine granular designer and developers. In this phase, we use existing models of DIME and also develop new reusable model as per as our project requirement. This phase also includes model to code generation, and it builds a running application that is further examined, updated, and redeployed. At the last phase, application execution and testing phase, the historians and other users test and use the application. This is the validation and use phase of the current version of the application. It includes live debugging, error handling, fixing, as well as defining of new features and challenges for the next development. Now I would like to discuss about the Historian app, which is completely developed in a low-code environment using DIME. DIME mainly involves four types of models. A data model of DIME application represents both concrete and abstract data. Process model expresses the business logic in fashion roughly similar to the activity diagram. Very simply, each process type follows certain rules regarding which kind of SIPs they contain and what kind of tasks they perform. A GUI model type represent the structure of DIME's web page. A collection of GUI model define the abstract and concrete look of the presentation layer of DIME application. The GUI model called the process model to execute an operation. In DIME, the action and services are collected in domain-specific palettes that basically is a service component-oriented DSL. The DSL elements correspond to the individual functionality that are either directly implemented or provided by external service provider. The individual functionalities are modeled as a specific native types called native SIPs or service-oriented building blocks, which enables interoperability in the structural level. So in this figure, I'm presenting the overview of Historian app. This shows the interplay among process, GUI, actions, and evil handlers. In our project involves two roles. So a successful login as a student directly links to the entry table page. A GUI model, where students can see all the entries recorded by him or her. Action add new entry leads the user to the create entry home page, a GUI model which calls create entry process. On the entry home page, users enter the data from the TIFF file to the web page fields. Create entry is a big process. It receives data entered by the user, and to do so in an error-free way, it calls all the other processes that provide support functionalities. It uses get pre-population process for reading pre-populated data from file and autofilling this to the entry form. Get suggestion provides pre-populated option in the web application as drop-down menu for certain data attributes such as register name. Create address process, create new address object and create time duration process creates duration object from various properties. Create entry performs all the individual operation needed to successfully save an entry. Even listeners on the create entry process help check the data validity and show alert messages in case of wrong entry. Finally, the action save entry on the entry form successfully saves the entry and gets back the user to the entry table again. At the entry table, selecting an entry go to the entry detail GUI where user can see, edit, and submit the entry. And the delete option is only available to the supervisor role. In a supervisor role, a successful login directly links to the entry table. Supervisor can also see all the submitted and approved entries individually. Supervisor have a validation and approval function. They can see the details of all the entries stored by student user and perform edits, approve, as well as remove the entry. Selecting manage user links the supervisor to user table page, and it glues all the user, and add user creates a new user to the application. Similarly, as create entry, create user performs all the operation necessary to create an user, and all the event handlers included here it creates alerts in case of any error. After saving the user, the supervisor can also edit the user or remove the user using edit user or remove user process. Supervisor can also perform an import and export data operation, and the issues are also handled using some event listeners. So here I am presenting the complete illustrating. Here I have presented the completely illustrate this figure completely illustrate the feature level abstract architecture of history and die map, and it also represents how we have developed a complete responsive web application for DBD-IRS data entry only using the 4 main model types of DIME. Here I'm presenting the create entry process that I have just talked about, and you can see this process starts, goes through all the other processes, collect their output, and store an entry successfully. Now I am presenting the data transcription evolution of DBD-IRL. DBD-IRL have been organizing yearly transcribathon at UL for speeding up the data entry process, where students participate in digitalizing the data. We started our model-driven development at the generation 3, 2019 to 2020. And here I am talking about the 4th generation of the data transcription, which took place at 15th of April 2021 using our proposed historian die map application. The main challenges we are able to solve at the version 2 is defining the major context parameter, user interface, adaptation at runtime, data entry with minimal error. So at version 2, modeling, adaptation, transformation, and execution of process and GUI resulted in a successful transcription of DBD-IRL's datathon. To address various runtime error, we introduce a alert model with event handlers. We introduce native safes for several condition check, whether an unidirectional space is used in an entry, a required field is left unattended, ID is not required, ID is not given, etc. Process events are connected with those detection, and respective event listeners are introduced at the corresponding GUI model to perform runtime error handling. Here is an example scenario which shows an event and corresponding event listener model connected with respective alert system that warns the user that the name can't have a special character. To ensure data accuracy, we have embedded suggestion information to the web application so that people can have option to choose from and store the current information. So here is a scenario. This drop-down menu enlists all the name of registers collected by our historian colleagues from the 19th Dublin State Directory, and we have created this component at the get suggestion process to get this list as a drop-down menu. So in case of digitalizing an entry, user can choose the correct option from the menu without any chance of error. In this paper, we have presented the first MDD-based application developed in DBD-IRL project to support the correct and reliable data entry of civil registration record. We explain how we co-developed a model-driven application with historian using integrated modeling environment. We briefly introduced the various model type and showed how they are used to create a coherent data process GUI and role-based access model. In particular, the version 2 greatly improves the archive data quality by making application reactive to content-specific events and equipping most of the data entry fields with pre-populated lists of possible options. The work is currently in progress. We're trying to adding more features to the application, and also we are working on the data analytics application in a low-code environment. Thank you. I would love to answer any of your queries, and these are the references.
Okay, thank you very much. Dear colleagues, any questions, please? Okay, I have a question. Do you deal with some classical problems of model-driven approach, like round-trip engineering or integration generated code and manually developed code?
Yeah, we're facing so many problems of this kind of related integration thing. So we are with the historian data, we are trying to show the data as a mapping, so that the historian can map the cause of deaths, etc. But in the low-code environment, still there is no existing data analytics platform. Also, some of the there are no. So we are trying to embed and integrate. Actually, my colleague that he has presented before, he is working on this integration tasks, so that we are trying to integrate all the analytics operations to the DIME, and we can just perform a complete application data analysis platform for the historians in a low-code environment, so that the historians can also participate in the application development.
Okay, thank you. Any other questions, please? No more questions. Thank you very much. Next presentation. PowerFX low-code language for collaboration tools. Ilya Voronkov.
Yeah, good day. Can you hear me?
Yeah, please.
Okay, thanks. I'm going
Share your
to
screen, please.
I'm sharing my screen. Can you see it?
Sorry?
I'm sharing my screen. Can you see it?
Yeah, I cannot see.
Okay, let's start again. Okay. Right now?
Now is okay. It's okay, yeah.
Okay.
Welcome.
Yeah, good morning, good day, colleagues. Yeah, my name is Ilya Voronkov. I'm from St. Petersburg Polytechnical University. And today I would like to introduce the PowerFX. It's a low-code language for collaboration tools. Let's start from some topics, talk about low-code and no-code development. So low-code development platforms provide a development environment used to create application software through a graphical user interface instead of traditional hand-coded computer programming. A low-code platform may produce entirely operation application or require additional coding to specific situation. Low-code development platforms reduce the amount of traditional hand coding, enabling accelerated delivery of business application. A common benefit is that a wide range of people can contribute to the application development, not only those people with formal programming skills. LCDPS can also lower the initial cost of setup, training, development, and maintenance. No-code development platforms allows programmers and non-programmers to create application software through graphical user interface and configuration instead of traditional computer programming. No-code development platforms are closely related with low-code development platforms, as both are desired to extend the application development process. These platforms both increased in popularity as the companies deals with parallel trends of an increasingly mobile workforce and limited supply of competent software developers. Platforms vary widely in their functionality, integrations, and market niche. Some application may focus on a specific business function, such as data capture or workflow, with others may seek to integrate to enterprise resource planning tools into a mobile form factor. No-code development platforms are also closely related to visual programming languages. According to the Gartner report, by the 2023, over 50% of medium or large enterprise will have adopted an LSAP of their strategic application platforms. This is the title of the manifesto. This manifesto was published by Emmanuel Strashnov. It's the founder of the Bible.io, is a billionaire corporate right now. For non-code services in 2014 in the Huffington Post, but it still reads like text from the future. The recording is not just new oil, it's the path of human development and liberation. Let me give you some quotes from this manifesto. Basic, one of the very first programming languages, celebrates its 50th birthday at the May of 2014, and yet modern program languages still reflect this archetypal approach. The way people program today is typically is typing highly structured text, the code in the text editor. We have to write things so that it's easy for the computer to parse them instead of being easy for us to read them. True, a lot has been done to make the coding process faster through better learning tools and code sharing, the open source movement. However, in spite of these efforts, you still need to be trained as engineer to build software. 50 years from now, the author can't imagine people programming as we do this today. It just can't be. The future we imagine, the author imagine, is a world in which programming is self-explanatory, where people talk to computers to build software. To get their programming tools should first use our language. For instance, to turn a button red, we shouldn't have to write code. We should just be able to point to the button and select a shade of red. Instead of talking about concepts the computer cares about, like variables, servers, and so on, programming tools should talk about things the programmer cares about, and imagine our close order. This could change everything in the way we live. With more accessible programming, farmers could program robots to intelligent tend crops based on local soil conditions. Teachers could build software to adjust their teaching based on what happened the day before around the school. Chefs could set up the system to buy fresh fish from the nearby market in real time as the people place orders. However, that won't happen if farmers, teachers, and chefs have to learn code to do it because it's no expertise. Instead, programming tools should be able to speak like a chef to a chef. Software tools should be created by users because the users, only the users know their needs better than anyone else. A software engineer will never know cooking as well as a chef does. Teaching people how to code to turn them into engineers is not the solution. The PowerFX is part of the Microsoft Power Platform. It's a group of products to develop and build complex business application, analyze and draw data visualizations, automate business processes, or build virtual agents for communication. All these products offer a platform in which no code is required to build the application. These products in the form as simple GUI which can be used of any business users of developers for helping us to reduce the need of IT organization. On 2nd March of 2021, Microsoft officially introduced the PowerFX, low-code programming language, which is based on the Excel function syntax. From my point of view, it's also extend with Link, C#, and something else. The PowerFX language is designed to set up process in the Power Platform, Microsoft platform for creating business solutions and automating routine tasks. It's a generic, declarative, and functional strongly typed programming language. PowerFX describes business logics in concise yet powerful formals. Much of the logic of this language can be reduced to one-line formula with enough expertise and control for more complex tasks. The goal of a language is to minimize the number of concepts a programmer needs to understand, ideally, no more than Excel user would already know. This is the formula from the Stack Overflow. Looks like an Excel view that search for a row in reverse order. And here is also the formula from PowerFX and Power Apps application with the same formula in which cell reference are replaced with reference to control properties. When the input control value changes, the label control automatically recalculates the formula and displays the new value. There are no on-change event handlers that are common in other languages. Here is the example of the gallery control from PowerFX and Power Platform. It's a real code from the real business application, and it's how it looks like. So in the left part of the screen, you can see it's if you just export this as a text on the top, it's how it looks like with formatting, and near there is it's the result view. It's the gallery control, where it's possible to search, sort, filtering using refiners, and so on. PowerFX links objects together in declarative spreadsheet formulas. For example, you can think of the visible property of the user interface control as a spreadsheet cell with an associated formula that calculates its values based on the properties of another control. The formula logic is recalculated automatically, similar to how it happens in the spreadsheet, which affects the visibility of the control. In addition, PowerFX offers imperative logic when needed. A spreadsheet usually don't have buttons that can submit changes to the database, but applications often do. The same expression language is used for both declarative and imperative logics. For example, it's possible to change the screen that displayed, control a signal, enable or disable functions, refresh, update, remove, make CRUD operations on data storage, update the context variables, update functions, and create, update, remove items. Now it's the latest announce that has been done 2 days ago. It's extending the PowerFX and Power Platform. Microsoft has implemented the OpenAI GPT-3 natural language model into its own Power Apps platform. The innovation will allow you to create application in a dialogue mode. Power Apps will generate a formula from command that the user enters in the natural languages. For example, if the user needs to show the 10 orders that have stroller in the product, it will just type this by the natural world. And the result of the formula, the system will process the request and display several formulas. After this, user can choose one of them. Now, instead of memorizing and writing formulas, the user can simply enter the command. Based on the input and the application context, Power Apps will generate one or more of the most appropriate formulas, filtering out the results that fail syntax checking. After that, the user will select the formula that he needs. Formulas are generated in the open source PowerFX programming language based on Microsoft Excel. GPT-3 works on the basis of the Microsoft Azure Cloud Service, and the Azure Machine Learning Service was used for additional training of the neural network. Microsoft emphasizes that while technology can make it easier to build application, it doesn't replace understanding the code. The company notes that the innovation is more likely to help people who decide to study PowerFX, making it easy to choose the right formulas. Public testing of this feature in Power Apps will begin at June this year. Going forward, it's also have planned to introduce this GPT-3 mechanism to all other low-code platforms from the company, and also extend the PowerFX using not only for Power Apps application, but also for all other applications. That's all from my side. So please, if you have any questions.
Okay, thank you. Any questions?
May I ask a question? Hi.
Hi.
Tiziana Margaria, hi.
Yeah.
Yes, so I mean, of course, I'm the co-author of the previous two presentations, so I'm very interested in the low-code and no-code approaches, so that's of course great. One of the characteristics of our approach is that we try to have a formal model for all these diagrams, okay? So they are basically graphs and we can analyze them and they have this kind of characteristics. Are you aware whether this new technology from Microsoft also contains such a formal model in the background? So that the analysis is not just, let's say, at the epidermic level of programming, of code, but it is, with the models, with the graphs, Petri nets, whatever they can use, so to say, in the back.
Yes, I can try to explain this. I work a little bit with this, create some projects, and there are also the possibility to have this data analysis on the background of the system, but also there are another extents on each products, which names is graph applications. Microsoft Graph application, which in my point of view is looks similar for the approach that you was presented. So it's possible to work with this like this way.
Okay, thank you very much.
Thanks.
Okay. I have a question. Could you explain briefly the contribution of your research? Summarizing all words.
Yeah, the contribution work, firstly, it's in progress right now. We are not finished. So it's going to be finished when we finally are testing the GPT-3 approach. We have a task to create the application. There were two approaches of this. One of them is using the Power Platform for this one, and for the other one, it's the used programming tools, which consist of SPFX. It's a special framework for such solutions, and we would like to compare the results of the efforts that we need. And it seems like that the creation, the same functionality in Power Apps will cost at least three less time than we using its SPFX. So the final result of this approach, when we will give the final results, we will add this information to the final research paper and we'll publish it.
Okay, thank you. Any other questions? Okay, thank you very much. The next presentation is a multi-layer approach to subgraphs matching in HP graphs.
Yeah.
Nikolai Suvorov. Yeah?
Yeah.
Are you ready?
Yes. Can you see my screen?
Yeah. It's okay.
Yeah. Hello, dear audience. My name is Nikolai Suvorov, and in my presentation today, I'd like to present you a multi-layer approach to subgraph matching in HP graphs. Second. Yeah. In practice, a task of finding an isomorphic subgraph has a wide range of applications, including protein interaction analysis, social network analysis, pattern recognition, and chemical compound search. However, subgraph matching is a bottleneck in most of these applications due to the fact that this task is NP hard. For instance, nodes count for protein interaction analysis can reach up to tens of thousands. Thus, active efforts are currently being made to find an optimal algorithm for subgraph matching. Isomorphic subgraph searching is also used in model transformations. Such transformations allow users to move from one modeling language to another or from one level of abstraction to another. These transformations can detail models or create new models when moving to a new task while preserving the common elements of the previously built models. These transformations can also be used in model refactoring and in simulation modeling. As visual languages are usually presented as graphs, a model transformation rule includes a task of searching a subgraph which is isomorphic to a user-defined pattern, which is presented in the left part of the rule. While a whole transformation can include dozens of rules, it is important to optimize a task of isomorphic subgraph search to increase speed of model transformations. The idea to decrease complexity is to split the search into several layers, where each next level details the previous one. For instance, on a first layer, only structural characteristics can be taken into account. And if a candidate for isomorphism is found, the algorithm moves to a next layer, where the semantic characteristics are compared. And if the candidate is verified on the second layer, the matching is added to the answer. This approach helps to decrease quantity of comparing operations and thus helps decrease the overall complexity of the algorithm. Previously, a knowledge-based DSM platform has been proposed to solve some limitations of the existing DSM platforms. And to implement the language tools of this platform, a meta-language for creating and working with domain-specific languages has been developed. The mathematical basis for this implementation is HP graphs, which provide the ability to optimize algorithms for performing operation and models, including model transformations. An HP graph is an ordered triple, where P is a set of external poles of the graph, V is a non-empty set of mutually disjoint vertices consisting of internal poles, and W is a set of hyperedges consisting of poles and links. Visual languages can be represented as various types of graphs, including oriented graphs, hypergraphs, high graphs, metagraphs, and p-graphs. But the HP graph model unites expressive possibilities of all these types of graphs, and thus it can be used for building more complicated models than those which can be built with the help of these models. Moreover, algorithms that are designed for these graph types, particularly model transformation algorithms, can also be implemented on HP graphs. Now, let's take an example of presenting a diagram in terms of an HP graph. An IDEF0 diagram of business process of given book is presented on the slide. First of all line endpoints are presented as poles. These poles can be inputs or outputs of processes or represent external elements. Then let's combine lines and line endpoints into various sample sets. As a seen, certain poles can exist in various sets simultaneously, as a pole librarian in the bottom of this picture. Then all these sets are presented as hyperedges. In HP graphs, poles can be either input and output or output. Each hyperedge must contain at least one input pole and one output pole. And to present this feature, all the poles were labeled and marked depending on their input or output state. The problem of subgraph matching has been investigated for many years, and lots of algorithms have been presented to decrease the complexity of this operation. Most of these algorithms use backtracking to move through a search tree and find the appropriate combinations of vertices of pattern graph and the source graph. These algorithms use various techniques to decrease time needed for matching, and most of these techniques can be divided into three main groups, which are presented on the slide. However, the most of the theoretical research of the problem of subgraph matching has been conducted specifically for ordinary graphs. That is why these approaches have to be adapted to a presented HP graph model. The purpose of this work is to develop an approach to decrease complexity of subgraph matching algorithms performed on the HP graphs. In particular, the work presents a multi-layer approach to subgraph meshing, a backtracking algorithm based on this approach, and certain adaptations of the existing algorithms to a proposed approach. As for the HP graph, no algorithm has been proposed to perform an isomorphic subgraph search operation. The structural complexity of the graph model requires modifying the existing algorithms to adapt them to this model. The HP graph has a multi-layer structure which can be divided into two layers, the layer of hyperedge and vertices, and the layer of poles and links, the sets of which are the elements of which are combined into the sets of the previous layer. A multi-layer structure can reduce time complexity of search operations. The number of operations can be reduced due to the fact that the first search and meshing is performed on the layer of vertices and hyperedges. And if a subgraph with the desired characteristics is found, the algorithm moves to a more detailed level where the comparison of the corresponding poles and links is performed. The figure on this slide demonstrates an example of a query graph and a source graph at the start of the algorithm. As is seen, both these graphs contain vertices, hyperedges, and poles. And on the first layer of the algorithm, all internal poles of vertices are eliminated. And only vertices, hyperedges, and external poles are taken into account. The first layer of the query graph is compared with the first layer of the source graph. And if a candidate for isomorphism is found, the algorithm moves to the next level where the corresponding hyperedges and their poles are compared. All the candidate hyperedges are grouped by their instance with each other depending on the poles which they consist of. All these groups are compared on the exact isomorphism on the layer of poles and ordinary links. So these hyperedges are decomposed and only their poles and links are taken into account into this step. If a validation of a current candidate group is succeeded, the algorithm moves to the next hyperedge group until all hyperedges of the pattern graph are traversed. If validation fails, the algorithm moves to a previous level and tries to find new combinations of vertices and hyperedges. The backtracking algorithm based on this approach is presented on the slide. This algorithm traverses a search tree using the depth-first search until an isomorphic subgraph is found. If a pair of corresponding elements cannot be found at a certain step, the algorithm moves to the previous level. Considering the division of the algorithm into several layers, the search algorithm should be modified to perform the search separately at the vertex level, separately at the hyperedge level, and separately at the pole level. Firstly, the vertices meshing is performed. On this stage, vertices and external poles are combined into one set. If a candidate for isomorphism is found, the algorithm moves to the next level, where the comparison of hyperedges incident to those vertices is performed. The matching of incident vertices is also taken into account while comparing the hyperedges of graphs. If the matching is done successfully, all the hyperedges are grouped by their incidence. And for each of the hyperedge group, the pole matching is performed. If the matching is failed for any group, the algorithm moves to a previous level. Finally, the matching of isolated poles is performed. By isolated poles, we mean those which do not have any incident hyperedges. After that, the answer is generated, and for simplicity, this algorithm is given for getting only the first isomorphic subgraph, but can be transformed for searching for all embeddings of the pattern. The main idea of the algorithm is to incrementally shorten the search field of it. The search for vertices traverses all the vertices of a source graph, but the search for hyperedges only goes through those hyperedges which are incident to the already matched vertices. Pole matching is performed for each hyperedge group, and a sufficient quantity of several existing algorithms were adapted to the proposed approach. Pullman algorithm is one of the first algorithms for subgraph searching. This algorithm uses backtracking, and at each step it performs a refinement procedure to print out and promising pairs. This algorithm can be implemented on both vertex level and pole level. The refinement algorithm for the vertex level is presented on the slide, and the algorithm goes for all the neighbors of the current query vertex, and which have at least one common hyperedge with this vertex, and checks whether a source graph contains a corresponding neighbor vertex. The algorithm for poles looks similarly, but instead of vertices and hyperedges, poles and links are used. The Vf2 algorithm has been proposed for performing a subgraph search on large graphs. The idea of the algorithm is to use special rules called feasibility rules at each node of a search tree to evaluate the feasibility of further progress on this branch of tree. An approach of checking the feasibility rules can be applied on both vertex level and pole level. While a pole layer can be represented as an ordinary graph, there is no need to significantly change these feasibility rules. But the feasibility rules for a vertex level were needed to be redefined. The high-level Vf2 algorithm for vertices traversing is presented on the slide. As I seen, this algorithm also implements a multi-layer approach by calling a procedure for subgraph matching on the hyperedge level. In addition, for this algorithm, the operation for getting all candidate pairs was also modified according to the rules of initializing matrices, which were presented earlier. It slightly increases worst case and best case complexity of the algorithm, but helps to significantly shorten the size of a search tree. The usage of algorithms such as table ISO, CFL match, and other ones that change a graph pattern is complicated in the presented multi-layer approach because these algorithms are developed specifically for ordinary graphs. Their usage on the layer of vertices and hyperedges is a subject for future research, as it requires reformulation of their main aspects and ideas. And nevertheless, all these algorithms can be performed on the layer on poles and links, and they can successfully find an isomorphic subgraph in terms of a single layer approach. And the complexity of the main steps of the table ISO algorithm are presented on the slide. The adapted algorithms can decrease the complexity of subgraph search by implementing a matching on different graph layers, and by using special pruning rules to eliminate unpromising combinations of elements. Tables on this slide demonstrate the computational complexity of presented backtracking algorithm, Pullman algorithm, and the Vf2 algorithm. The paper proposed a solution to the problem of identifying isomorphic subgraphs in HP graphs. By implementing matching on different graph layers, the proposed approach incrementally decreases the search field of the algorithm and helps to decrease its overall complexity. The usage of pruning rules of the existing algorithms can eliminate unpromising candidates at each stage of a proposed algorithm and thus significantly shorten the size of a search tree. It is planned to evaluate actual time complexity of these algorithms on various data sets and develop a visual modeling system using the proposed approach to subgraph matching in model transformations. The usage of the algorithm is not limited only to model transformations and possibly can be applied to solve tasks using graph models in various subject areas. Thanks for your attention, and now ready to answer your questions.
Okay, thank you. Any questions, dear colleagues, please? And I have a question concerning IHP graphs. Do you have any idea how to use existing modeling frameworks like Eclipse modeling tools or something like this to implement IHP graphs? How it could be done?
Frankly speaking, I would skip to the architecture. We're developing our own so-called DSM platform, which would base on this HP graph model. I guess that it will be quite difficult to use the existing frameworks to make a modeling system based on the HP graph. But potentially, there is a module of import and export, and it would be possible. The system would try to would make possible import of models which are created on the eCore meta language, so from the Eclipse system, and they can be used in this system. But of course, it requires a lot of work to make such mappings between meta languages and make operations of these transformations of meta languages.
Okay, thank you very much. Any more questions, please? No questions. Thank you very much.
Thank you.
Yeah, and our session is completed now. Thank you for your contribution and for your attention. So, coffee break.